here. Can you be brave, please, and tell me how to find the vertex of this, please? Go ahead. Go ahead. You can keep talking. I'm looking for a marker. Yeah. Yeah. Well, you said minus 4x. Right, because it's like right negative 3 times negative 4 is positive 12.
Do you only want us to draw one?
What's that?
Do you want us to draw one?
No, I'll draw them both here. Okay. All right, Owen, can I see this, please? Owen, go ahead. Next step, please.
So we do the little arrow.
Yeah.
And then it's in brackets negative 1 over 2 squared.
Yeah.
And then that equals negative 2 squared.
Yeah.
And that,
All right. I hate to normally. I don't like yelling. I don't like yelling, but I also don't like whispering when I'm trying to do my thing up here. It's very hard to concentrate. I'm sorry about that. All right. Cool. Austin. Next step here, please. What?
Adams and Calvin form.
Okay. Okay, great. Next step, please. Go ahead. Go ahead. Yeah. Yeah.
So then you just take the negative 4 out and times by negative 3.
Change the plus 12 minus 8. Okay, great. Summer, go ahead. Okay. All right, Jessica, what is my vertex and which way is it open, please?
Negative 2. I mean 2.
Good.
4.
Good.
Opens down.
Good. Okay, now, although you got some help with the negative 2 thing, okay, remember, it's always the opposite of what's in the bracket. Okay, so because it's negative 2 in there, it's really the opposite of positive 2. Like the regular equation is this one, right? Right, that's the regular equation, so the vertex is h comma k, so it's going to be the opposite number of what's in there. That's just how it always works. All right. Okay, the second Alana. Can you tell me, please? You're the first Alana. You're the second Alana now. Second Alana, what's the vertex of the inverse, please?
4 and 2.
Good. Okay. And we'll figure out which way it opens here in a sec. And if you already know, that's good. You should probably know from our warm today. That'll help out, right, how it's going to look, okay? So I'm going to do a rough sketch of this. I'm going to do it on graph paper because I'm good like that. Okay, right? But I'm not going to worry about the roots for this. You just need to find your vertex. That's all you need. Okay, so here we go. I'm going to do this on graph paper because I like graph paper.
so we want us to find the roots for fx as you go, like over the half.
What's that, sir?
Would you want us to find the roots for like, the main range?
Yes.
Like the fx as ultimately half?
Yes, definitely, yeah. And that's what we're going to, yes. I'll draw the whole thing when I talk about the half, because that's the whole point of this question, right, is to get to go. Okay, so I need 4 and 2. So I'll put my equation over here someplace. Excuse me. Okay, so if you take a look what Olivia did, this is perfect as far as graphs go. Again, 4 on one side, 4 on the other, that's perfect enough side for what it's okay, right? For this, that's all you need for a graph. If you want to do a giant graph, that's okay, I'm not going to punish you, but that's big enough size for graphs in this course, okay? So I gotta get to 4, so 0, 1, 2, that's maybe not going to work. There's my x-axis. There's 0, 1, 2, 3, 4, 5, 6. So I'm going to draw f of x first, which is going to be 2 and 4 and opening downward. It looks something like this. And there's f of x. Okay. hopefully we're all okay on that, 'cause we've done a million of these last year and this year, right? The problem comes downwards, there's its vertex. Any question on that before I keep going? Yeah, go ahead.
So on our test, will you have to tell us, if we have to find the roots or not?
Yeah, definitely, okay?
So
The only ones, the only way I will, if you have to find roots, I'll say, use the 4 points method, so that'd be
Okay.
like the roots, okay? Because for this, because it's only domain and range that we care about, the roots don't tell us anything about the domain, right?
And then, will we have to tell you how we got each individual point, or will we okay if we just like mark them down?
What do you mean?
Like you know how we have to get the opposite points? Would we have to tell you, well, since this point is this, that means the f negative 1x must be this?
Well, you'd have to tell, all I need to see is this, right?
Okay.
I need to say, like, if you have your regular points, then
Yeah.
I want you to say F inverse and just flip them differently.
Okay.
Then do you have a question there, or?
Yeah, how, did you know how wide?
It doesn't matter for this, okay? So, like, not that it doesn't matter. It's just an estimate for this, okay? Because, as I was just trying to say for this, the only thing we care about is the domain and the range. Okay, so whether the root is here, or right here, it's still on the same domain and range, okay, for this. So, yeah, if I want you, just what I was saying, if I want you the roots and all that, I'll tell you on the, on your test. Okay, so there we go. All right. Yes. Sorry, go ahead.
Fluid in just one, I get one's like 4,
Yeah.
1, 2,
Yeah.
but.
Just kidding? I'll get to that, just wait, we're way ahead of ourselves here, way ahead of ourselves, okay? Leah, I'm gonna pick on you first. Will this graph be open leftwards or rightwards, and how do we know? Yes, it is.
I don't know.
Okay, the hint is I'm gonna tell you guys for this. Somebody wanna add something here? Okay, the hint I'm gonna tell you for this is, if you think of the idea that you're switching here, because this has 2 x-intercepts, what does that tell you about your y-intercept? Or sorry, what about your inverse? 2 y-intercepts, okay? So this one's gonna go over something like this. If you don't like that idea, if you're like, Mr. Sadler, that's way too complicated for me, I'm just a simple math student. You can also say, well, it goes like a clock, it goes in a circle. So if this is your function, the inverse is going this way, and if this is your function, the inverse is going that way. Okay? The better way to think is with intercepts, so that's what I think. Okay? So 2 x-intercepts for f of x, that means 2 y-intercepts for. All right, now for Liam's question, how do you know which side to cut off and all that sort of stuff? It does not matter. Okay, so let's say that you say you want to just use the right-hand arm, ignore the left. How would you write the domain if you just want to use the right-hand arm of the red? Liam, go ahead. Very good. So for part B, we're going to say my domain greater than or equal to 2 XER. And where he got that from, that was the x coordinate of vertex. Okay, so you see what he did there, right? That was the x coordinate of the vertex. Do that. Okay, can I now have Brave Soul named Grace tell me what the range of the red graph is, please?
Y is less than or equal to 4.
Great. All right, Jennifer, I would like to use your great knowledge of math to tell me what the domain of the green graph is, please. Great. The other way to think, yes, so it's going to be less than 4, good. The other way to think, right, remember, it's just going to be the range of this one, right? So you can go right to there and switch your x and your y. So you're going to say x is less than or equal to 4, XER. And then my range is going to be... Okay, so what Liam did there was quite remarkable. No one actually asked a question because I don't think everyone really understood what happened. All that Liam did, he said, which way do we want to go? He gets the idea you got to chop off one arm, right? He decided to chop off this arm right here. So he left just with x is greater than 2. So that's what he did, write that in his domain, that x is greater than 2. Okay?
Should we chop off?
You could have chopped the other arm off too, right? So then that would have been, I should put that down here, sorry.
So could have, if we chopped off the other one, it would have been less than or equal to 2.
Where am I going to put that? Here?
Oh, do we have to put or?
No, you don't have to. Right, So as long as it's together, it doesn't matter too much, okay, right? So you basically get your vertex, either getting rid of this or getting rid of this up there, yeah. Wow, we're good. Stressed out yet? This is no problem. I was so stressed out as a teenager. Look at me now. No hair at all. If you're out listening to something, I have a full head of silver, beautiful hair. Okay, so just so you know. Yeah. You know my grandfather had silver hair, and he had like a full head of silver hair. So I thought like I was going white at like 20, I thought, yeah, no problem. So I ended up with my grandpa, silver full head of hair, 75 years old, beautiful, luscious even hair, and nothing there.
Relaxed now. He's pretty relaxed now.
Well, that's because, I don't know. Okay, good. I'm going to write your homework on the board. We're going to do one more of these to make sure life is good. Oh, it's not.
Is your twin brother home bald too? Yeah.
Or
I haven't seen him in a while.
okay, so what I'm going to do is this. Letter C. We're not quite done this one yet. Letter C, and please put a star beside this one. You are going to use vertex form to find the inverse of f of x. All right, Quinn, since it's up to you, can you give me the equation in vertex form we just graphed there? You look down your page, hopefully. F of x equals? I hope so. It's a question we just did. No? No. Somebody help her. Okay, I'll help her. There. -3 bracket. X minus 2 squared. Plus 4. That's the equation we want to find the inverse of. The reason we want to use this equation is because there is one x and there's one y. Now I'm saying this very slowly to you guys because people forget this and they're not going to solve it. They're not going to be able to solve it. Okay, so you have to use it vertex form. Okay, Quinn, you're not done yet. What is f of x the same as? Y. So I'm going to start with y equals -3. All right, Miss Hooper, what do we do to find an inverse? No. So now you switch x and y. Good. That's what I wanted you to say. So we're going to switch f for x and y, and we're going to solve for y. Whoops. Now we're going to get a funky equation here. Okay, so if you're fading out of today's class and saying, "Man, I wish it was Valentine's Day," don't worry, it's not until tomorrow. Is there anyone here on Students' Council, by the way?
Yeah.
Okay, I gotta talk to you. Seriously. Okay, so I gotta solve for y here. So I'm gonna ask for brave volunteers here. To solve for y, what's the first step going to be to solve for y?
You expand that.
You definitely should not. Okay, now the reason is because, sorry, I meant to say say I'm sorry, that's incorrect. Let's work together to get our proper solution. How are you? Okay. Who are you passing notes to? All right, so I meant, sorry, Olivia, I didn't mean to say it like that. I meant to say, I'm sorry, that's incorrect. Let's work together as a class to fix the solution. The problem is, if you were to FOIL this out, you end up with a y squared, a y, and a number. And it's difficult to solve for y when you have three, you have more than one variable there. So if I want to get y by itself, what's the first thing I can do to isolate it? Go ahead. Move forward. Sounds good. So we're going to have x minus 4 equals -3 y minus 2 squared. Okay. So this is where my joke comes in. I'm sorry about this joke. The math teacher's like an ogre. He has many layers. Get it?
Is that
Can I see Shrek? Can I see
Yeah.
Shrek? Okay. The idea is here for when you're solving for algebra here. Okay. You take off the layer the furthest away from the y. So this is the one that's the furthest away moved across. What's the next furthest thing away from the y, please? negative 3. Okay, so it's going to be x minus 4 divided by negative 3 equals y minus 2 squared. Now, before you think of FOILing, we're not going to. How do you get rid of a squared? Square root, good. Now, the reason this should make sense, because remember we saw that the square root graph was sideways like this, right? So it makes sense that our answer should be in terms of the square root. I'm going to write plus or minus, right? Because the positive square root is up like this, the negative square root's down like that. Okay, so that's what makes the total square root graph. And then I'll move it over. Oh my goodness.
Please excuse the interruption. The following people are to report to the library: Rebecca Ross, Bradley Shaw, Sydney Griffin, Lydia Sickema, Beatrice Fowler Campbell, Richard Acton, Baby Alderman, and Emily Moser. Again, the following people please report to the library: Rebecca Ross, Bradley Shaw, Sydney Griffin, Lydia Sickema, Beatrice Fowler Campbell, Richard Acton, Baby Alderman, and Emily Moser. Thank you.
Now I'm going to Bradley.
Okay, good? It is interesting. Well, this is right hand side. So this is just algebra, is all it was, okay? It's like solving for x, if it happens to be an x squared in there. That's the only difference. Now, you could FOIL out the y minus 2. I shouldn't have yelled at you when you offered that. What would have happened is you would have used the quadratic formula to get that answer, and you wouldn't want to do that, right? I don't think so.
I feel like I'm ready to leave. Ready.
All right, I'm going to homework on the board, and we might start one more on this thing. Homework's going to be page 161. Yeah, I don't know.
Or what if the summer film was 14?
Yeah, it's not.
Because, you know.